Hi guys, this is the lesson about coterminal angle as well as the reference angle, but we're going to call it now a related acute angle. In the previous lesson video, I told you that sometimes we use related acute angle for the reference angle. They actually are used interchangeably. So here, then we have a coterminal angles, but before we start, there are a couple of things that we need to know. See that these Greek letters, one's called the theta. The theta looks like that, and the alpha and the beta. Now, these are not just a regular Greek letters that we use to read A, B, C, D, E, and F. These actually represent angles. So when I say cosine theta, that means cosine of an angle that we don't know. You can kind of think of it as an x. Okay, x is as a variable that we don't know the specific value for. The same thing here. And then we know that the standard position, it's at the origin. The, the initial arm is at the origin, and then we go this way, the counterclockwise. That's basically the standard position. Now, in terms of the positive and negative angle, as we know, the counterclockwise, meaning going this way, we read it as a positive angle. So, for example, positive 30, positive 60, positive 210, and on. But when you actually rotate your terminal arm the other way, which is the clockwise, then we read it as a negative angle. So we can say negative 30 degrees if you only rotate this much. If you rotate, let's say, that much, we can say that it's negative 120, etc., etc. Okay. Now, so then when you are looking at the coterminal angles, first we need to know what the coterminal angle is. I already explained that to you in the lesson. So coterminal angle is an angle that gives you the same trig ratio as a reference angle per se. So in this case, if you look at the 45 degrees, and the 405 actually is another line. This is 405 after a one full rotation. And then 765 is actually the same angle after two rotations, right? And this is 45. So these three are coterminal angles since they will give the same trigonometric ratio. So for example, sine 45 will be the same as sine 405, and it will be the same as sine 765. And another one can be tangent 45 is the same as tangent 405 and the same as tangent 765. There can be many, right? Depending on how many rotations you do. So in this case, we're just going to show only three for now. Okay. So these are the coterminal angles. So coterminal angles is the angles that give the same end position of the terminal arm, which gives the same trig ratio. So in the example here, find the coterminal angle of each from 0 to only 360 degrees. I restricted that from 0 to 360 because there are infinite number of coterminal angles. Now ignore that cosine here. So if you're looking at 225, if you look at the 225 is 180, and then plus 45 degrees. So the arm is right here. Now, if you're looking at it, then something that can give you, well, actually, let's not get rid of the cosine. Something that can give you the same, actually change this to 360 to 720, okay? So then the 225, its coterminal angle will be one more rotation, right? So it will be 225 plus 360 degrees, which gives me then 585 degrees. So this actually is the coterminal angle for the 225 degrees from 360 to 720. If I ask you something in between, let's say 720 and another next to rotation, then basically you add another 360 to this. Now here, then I'm going to forget. So this one, I'm going to just ignore, and I rather just do this one for from 0 to 360 and see whether we can do this. Okay, so 405 means that after full rotation we have to go 45 more degrees, right? So this is 45 more degrees. So then that means my terminal angle actually is residing in the first quadrant with the reference angle of 45 degrees. So the coterminal angle from, let's say, 0 to 360 will be just a 45 degrees. So the very first step is to draw where the angle is, and basically you add a full rotation, which is 360, or you subtract the 360, etc., to find the answer within that given domain, per se. Now, then, if it is the negative 135 degrees, now the negative 135, we go backwards, right? We go backwards. We go backwards. Now, how do I know this is negative 135? Well, we know that this is 90 degrees, right? And we go 45 more degrees, and that's basically negative 145 degrees, so 135 degrees. So by looking at this, if it was from, let's say, 0 to 360, now in this case, I'm going to actually change it to, let's say, 720 to 1080, okay? So when you have this, the well will be basically located, right? So this one, in terms of the positive angle wise, it is actually located at 225 degrees, right? Because 180 plus another 45. And we need to put this in between the 720 and 1080. So we just need to keep adding 360. Now I add 360 twice because this actually becomes a 720, and actually our starting point is a 720. So then this actually becomes 945 degrees, and as we can see that this coterminal angle of 945 sits in between 720 and 180. Okay, so again, the coterminal angle is basically an angle that gives you the same trig ratios. Okay. Now, having said that, then let's go into the part two. So the part two is then how we can use the Kest rule and the coterminal angle to find the angle when we're dealing with a coordinate. So before we assumed that we were just using a unit circle, now we're getting out of it. Okay, so that means that our radius of a circle can be more than just one or less than one. Okay, now for the Kest rule, we know that it's going to be CAST. Now, then using this, hopefully you remember it. Now, the radius is basically the a squared plus b squared. So in this case, this point is 1 comma square root of 3. So that means that the length here, or the height here, is square root of 3. The length here is 1. And that means that it's square root of 1 squared plus square root of 3 squared. And that gives me square root of 4, which is 2. So our radius is 2. Now, using this triangle, we're going to find out what the sine theta ratio is. We're not looking for the angle for now. We're just looking for the sine ratio for this angle. Now, it's opposite over adjacent, sorry, opposite over hypotenuse. So it is a square root of 3 over 2. Now, cosine then is 1 over 2, since it's adjacent over hypotenuse. Then the tangent is opposite over adjacent. So this is square root of 3 over 1. Now, using your special angle table, you should know that the theta in this case is 60 degrees. It's not the 120 or it's not the other angles, because 60 degrees is the only angle that gives all three ratios with these values. Now, hopefully you kind of notice it. It seems like square root of 3, we have it right here in the y value, right? And then 1 right here is actually the x value, and 2, which are at the bottom, is the r value. So we can kind of assume that, oh, maybe sine theta is y over r. Cos theta is then x over r. Now then the tangent theta can be, if you can look at it, it's y over x. So let's assume this and see whether it's actually true. So let's actually try that with the next one. So this time the point of intersection of the arm and the angle, sorry, not the angle, and the circle is -1 comma -1. So it is -1 comma -1. Now remember that you're always drawing the straight line down to form a right angle triangle to the x-axis. Okay, never the y-axis. Don't ever draw the line to the y-axis. Okay, only to the x-axis. Now we know that then this length is 1, this length is 1. Now using our r, we know that it's going to be 1 squared plus 1 squared, which is square root of 2. So we know that this is square root of 2. Now then let's actually try to find this. So assuming that this is the principal angle of the rotation, which is the theta in this case, is the sine theta. Now using this, we know that from the previous lesson that we have to follow the Kest rule. Now according to Kest rule, it's a C-A-S-T in this manner. Sine is going to be always the negative, right? Sine is always the negative in the third quadrant, and sine is opposite over hypotenuse. So in this case, it will be 1 over square root of 2. Now, same thing here for the cosine theta. Cosine theta will be, again, cosine is negative in the third, so it's negative. And it is adjacent over hypotenuse, so 1 over square root of 2. What about the tangent theta? Well, tangent is positive here. Therefore, we can simply say it is 1 over 1, which is 1. So let's actually see whether this formula follows in this case as well. So using this formula only, I'm going to get sine theta as y over r. So in this case, my y is negative 1 over r, which is square root of 2. But this basically we can say it's negative the whole thing over 1 over 2. The cosine theta then is x over r, which is then again negative 1 over square root of 2, which we can say negative 1 over square root of 2. And then lastly, tangent theta is x over r, which is negative 1 over negative 1. But this actually is just 1 over 1, since the negative signs actually cancel each other out from the numerator to the denominator. So when you are given a coordinate, we can say that sine theta is always y over r, cosine is x over r, and tangent is y over x. This is a formula that you actually have to remember of. So sine theta, we just summarize this. Sine theta is y over r, cosine is x over r, tangent is then y over x. Now r, I have just put 3, but we can simply just put r is basically x squared plus y squared, and then take the whole thing square root of it, since it's the hypotenuse length. Now, then going to the next slide, it's now all practice. So for in this case, it says find the sine, cosine, and tangent ratio if the terminal arm is connected to 3, 5. So always just to make sure, what I do is I just draw the Cartesian plane and then I put the arm, and we know that this is 3, 5. Okay. So my r is going to be square root of 3 squared plus 5 squared, which is then 3, which is, what is this, 9 plus 25, and that gives me square root of 34. So my sine theta is always then y over r, which then is 5 over square root of 34. Cosine will be then, what is cosine? X over r. So this then will be 3 over square root of 34. And then tangent is, we know that it is y over x. And y is 5, x is 3. So that's my ratio. Okay. Now another example is pretty much the same thing. Now then in this case is as find the sine, cosine, tangent ratio if the terminal arm is at negative 2, 4. So the same thing, it will be square root of negative 2 squared plus 4 squared. Now some of you may question me, doesn't it have to be 2? Well, it really doesn't matter, because 2 squared, negative 2 squared, it will actually give you the same answer anyway. So if you want to put it as a positive 2, that's completely fine, since actually it just represents the length of a side. Now then that will be 4 plus 16, that's square root of 20. Now then in this case, hopefully you remember that the square root of 20 is a 2 square root of 5. Okay, so you always have to actually simplify as much as possible. Now sine theta again is y over r, and this case is 4 over 2 square root of 5, which gives me 2 over square root of 5. Now cosine theta is then x over r, which in this case is negative 2 over 2 square root of 5, then which is negative 1 over square root of 5. Now tangent theta is, what is tangent theta? Tangent theta is then x over, what am I saying? Y over x. So it will be 4 over -2, which is then -2. Now, if you actually then think of it, it kind of makes sense because the point here is located at -2, 4, which is right there. And that's the second quadrant. Now, according to the Kest rules, in the second quadrant, all the ratios, only the sine ratio will be positive and cosine and tangent will be negative. And as you can see, the sine theta is positive, whereas the cosine theta and the tangent theta are both negative. So it does make sense. So at the end, it's actually a good habit to check using the Kest rule and the actual position of the coordinate. Okay. Now the next one is pretty much the same, but one step further. It actually asks you to find the actual angle, I believe. So it says the point -3, -5 is on the terminal arm of an angle of theta in the standard position. Now find the related acute angle, then find the principal angle. So basically, related acute angle is the angle between your terminal arm and the x-axis. The principal angle is how much you actually rotate from your standard position or the initial arm. So in this case, -3, -5 is somewhere along down here. Now, let's say then this is -3, -5. So that means my length here will be 3, my height here will be 5. So my r will be then square root of 3 squared plus 5 squared. Now, which gives me then square root of, I don't know, what is this? 9 plus 25, so 34. So we know that this is now square root of 34. Now, then we know that our sine theta ratio is going to be -5 over square root of 34. Now, square root of 34, we cannot simplify. That's why I'm not simplifying this. Now, then cosine theta is then -3 over square root of 34. Oh, did I put the point wrong? Oh, I put the point wrong. Sorry, my bad. Okay, so then it will be at here. So -3, -5. It's in the third quadrant. Now, then tangent theta will be at -5 over -3, which gives me 5 over 3. Oops, 5 over 5, 5 over 3. Now, then I'm going to put the related acute angle as a alpha and the principal angle as a theta. Okay, it's already here. Now, the alpha, which is in this case, so we just need to use a trigonometric ratio and a calculator. So you actually do need a calculator for this. Now, in this case, it is easier for you to actually use the ratio that has the positive, because time to time, when you're using a ratio which is a negative with your calculator to find the angle, sometimes it gives you, depending on the ratio, sometimes it gives you a negative angle, sometimes it gives you a obtuse angle, and on. So it's easier for you to actually use a positive ratio to find the related acute angle. So in this case, if you actually try to find the tangent theta of 5 over 3, so I'm going to put it as a tangent alpha, which actually is also 5 over 3. Now using your calculator, it will be alpha equals tangent inverse of 5 over 3. And I am actually doing it now. So tangent and then 5 over 3. It gives me 59 degrees. So that means this angle right here is 59 degrees. So this is my related acute angle. Then my principal angle will be 180 degrees plus 59 degrees, because theta is every angle, all the rotation from here to all the way here. So this then gives me 229, or sorry, 229, 239 degrees. We're almost done, okay? Now, same thing with the b. So -2, 4. So in this case, -2, 4 is actually located here. So -2, 4. So the height of this triangle will be, I'm going to move a little, will be 4. The length here will be 2. So your r will be square root of 2 squared plus 4 squared, which gives square root of 20, which is 2 square root of 5. Now, then obviously using the sine, let's say the theta. Remember, theta is the principal angle. The related acute angle is the alpha. So sine theta is then 4 over 2 square root of 5, which is then 2 over square root of 5. Cos theta is then negative 2 over 2 square root of 5, which is negative 1 over square root of 5. Now, tangent theta will be then 4. Sorry, not 4. Yeah, 4 over negative 2. So this is the negative 2. Now, just to double check, it's in the second quadrant and it's only the sign that's positive. Again, in order for you to find the reference angle alpha, we use a positive angle ratio, positive ratio. So using your calculator, we can say sine alpha is also the same as, also equal to 2 over square root of 5. And using that, we do the inverse sine of, so alpha is inverse sine of 2 over square root of 5. So 2 over square root of 5. Now that gives me 63.4 degrees. So your related acute angle, the reference angle is 63.4 degrees, whereas your principal angle will be 180 degrees minus 63.4 because the whole thing over here is 180, but theta is actually rotation that's less of the principal, that's less of the reference angle from the 180 degrees. That's why we're subtracting this. So this then becomes 16.6 degrees. So that's how we find the reference angle and the principal angle when the point is given to you. And these basically is the same. So I'm just going to go really quickly. Okay. Now 1 comma negative 3. So 1 comma negative 3 is down here. And we know that's 1 and negative 3. So the height is 3, the length is 1. So it will be r equals then 1 squared plus 3 squared, which is square root of 10. Now then sine theta is negative 3 over square root of 10. And cos theta is 1 over square root of 10. And then tangent theta is then negative 3 over 1. As you know, we have to use the positive angle ratio. So we know that the reference angle or the related acute angle is alpha, and then cosine alpha is the same as cosine theta, which is 1 over square root of 10. Therefore, alpha is inverse of square root of 10. And this gives me, now we're almost done. And 1 divided by square root of 10. And that gives me 71.6 degrees-ish. And then theta is 360 minus 71.6. And that gives me, what is 360 minus 71.6? That is 288.4 degrees. Okay. Now, last example is just another step. Now, if the sine theta is 5 over 13 and the terminal arm is in the first quadrant, it says in the first quadrant, now determine the other two primary trig ratio. So basically what it means is this. The sine theta, remember sine theta is always y over r. So this means that my y value is 5, my r value is 13. So that means, and it says the first quadrant, so it means that my r is 13, my y is 5, therefore my x is 12. Now how do I find the 12? Remember, the 13 squared equals 5 squared plus x squared, right? So if you do the calculation, then x becomes 12. So then the rest is very simple. Cosine theta, which is x over r, then is 12 over 13. And then tangent theta, which is y over x, then that is basically 5 over 12, right? Now, then b is slightly tricky. Now it says cosine theta is negative 4 over 7. Now we don't know then what number is negative, either 4 or 7, but it says quadrant 3. So it's in the quadrant 3, and we know that the cosine theta is then x over r. So we know that x is -4, r is 7. Now r cannot be negative. Remember, r is just the length of the hypotenuse line, which is the terminal arm's length. So it cannot be a negative, whereas the x is a coordinates value, so it can be negative. So that means x is a negative, and that actually makes sense, right? That actually makes sense. So the lengthwise, this is 7, this is 4. So we're just looking for the y value's length. So what we do is then 7 squared minus 4 squared equals y squared, and that is 49 minus 16, and that gives me 33. So then y's length is square root of 33. However, remember, this is sitting in a third quadrant, which gives the negative y value. So the actual y value, or the coordinate of this point, will be -4 comma negative square root of 33. Now using these, sine theta and tangent theta, we can easily find it, right? Now lastly, tangent theta is negative square root of 3. Same thing over here. Then it says, find the theta and then find the exact value. So it says find all possibilities. And let's actually see whether you can do this. We're going to take it up in class, okay? Well, we already probably took it up in class. All right. Thanks for watching. Sorry for having about 6-7 minutes over, but it was kind of longer than I thought. I don't know why. Anyway, see you guys in class. Bye.